Hello, class. We're going to get started on practicing the skill we worked on yesterday, and that is area model and partial quotient with division. So, we're going to get started by looking at our learning target. I am learning how to use strategies and algorithms, including the standard algorithm, to divide up to a 4-digit dividend by a 1-digit divisor. Our language objective for today is I can choose a strategy to represent a division problem and justify my thinking. Remember that these sentence stems, the first step in dividing is, next, then, finally, will help you think through the strategies of division because they're sequential. So I would encourage you to try using these. Let's go ahead and get started with solving a problem. Your work is located in Seesaw. And our first problem, Alexi has 65 gumballs. She shares them equally among her 4 friends and keeps the same amount for herself. How many gumballs does each person get? Okay, so when I look through, I've got a graph, like grid paper. I've got a pictorial model that I have to do and an algorithm. So it says she's sharing equally with, I'm going to do some highlighting. She has 65 gumballs. She shares them equally among 4 friends and keeps the same amount for herself. So I really have 5. 4 friends and herself. I also have equal, so I have equal parts, and I have a total. So that clues me in that I have a division problem. Notice how I marked up my text. This is important because it helps me understand the problem better. So my divisor is 5. On this grid, I would draw 5. 1, 2, 3, 4, 5. And I would label that side 5 because that is the factor of my area model, which is also the divisor. So remember that this is working backwards. So in my head, I have to think to myself, what times 5 is close to 65 and is something that I can multiply in my head? I can multiply 5 times 10 and I get 50. So I could go 10 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I go down, that is 50. I need to get to 65. I need to also label this side here, and I'm going to be plussing whatever I add. So it's like working backwards. Remember on the multiplication area model, you had your factors, so you knew each side. On this one, you know the interior, the total number of squares, so you're working backwards to solve this. So 65 minus 50 is 15. So I have 15 left. And what times 5 equals 15? 3. So I have to go 1, 2, 3, label the next piece of my side. This piece is 15. When I add that together, I get 65 total. So there's 65 total in here, which is exactly my total. 10 plus 3 is 13. So 65 divided by 5 equals 13. We're going to do this 2 more times, but in different ways. So this is our area model. Now, there's other ways that you can do an area model. You could draw 65 dots. That would take a while. So I'm actually just going to draw a square for this one. But I'm going to do my partial product, or not, partial quotient, excuse me. Partial quotient first. I'm setting up my partial quotient. And I'm going to make an L like I saw in the yesterday's video. That way I can keep track of what I'm doing. So I know I have 5. And I know that on the interior I have 65. And I'm having to try to figure out this other side of the area model. So the divisor's 5. I've got the dividend at 65. And I have a side I don't know, which I'm trying to figure out. And like up here, I know that 50 equals 10 times 5. So I'm going to go ahead and divide this and call this 50 because this is 10 times 5. So this side up here would be partially 10. Over here, I have to subtract 50 because that's a partial quotient. When I subtract 50, I'm left with 15. And over here, I need to write 10 because I multiplied 5 times 10 and got 50, and then I subtracted that. So that leaves 15 in my bit that's left. Up here earlier, we said that 5 times 3 equals 15. So 5 times 3 equals 15. I'm going to subtract that partial quotient, and I get 0. And then I'm also going to write a 3 in here, because that is how many times I times the 5. My final step is to add. So I add my partial quotients, and I get 13. 10 plus 3 equals 13. Now I can check my problem through the opposite operation of multiplication. So I'm going to try that over here. 13 times 5, and I should get 65. 3 times 5 is 5. I regroup my 1. 1 times 5 is 5, plus 1 is 6. So yay! 65 is my dividend. So if I look back up at my problem, I found out that each person is getting 15 cards. No, 13 cards, excuse me. 13 cards. Each person gets 13 cards. You have a couple more problems to do. There are actually 6, and it has room for a pictorial model and an algorithm. I would suggest trying the partial quotient as an algorithm. You can also estimate just to wrap your brain around about what your answer is going to be. But remember, estimating is not the answer. It is a way for you to get a reasonable number that will be close to your answer. So you have 6 problems to try. Good luck. Bye.